Okay, so today we're going to talk about waves, the basics, properties and basic calculations, types, longitudinal, transverse, and so on. I recommend you have a pen and paper handy because I'm going to get you to pause various points to attempt calculations. Let's start talking about what a wave actually is. It's basically nature's way of transferring energy from one point in space to another without the net movement of matter. So, for instance, if I press play on this video and very quickly mute it, you'll see that these waves are being produced by this oscillator on the left, and they're moving from left to right. If you look at one of the green balls, which make up part of this string, they're just oscillating up and down. They're not actually moving from left to right. Yet you can definitely see waves carrying energy from this side, the left, to the right. Okay, now let's look at some wave definitions. So I'm going to move up here. And what I'd like you to do is pause the video and attempt to write sentences to describe each of the four following things: amplitude, wavelength, time period and frequency, and then label the wave diagram as shown. Okay, so you can pause now. Answers in 3, 2, 1. Okay, there are the answers. There are other statements you could write, but those are the four I've chosen to write here. Hopefully you understand them, make sure you do. Compare them with your own. The symbols I've drawn in blue, so you can see lambda for wavelength, F for frequency, capital T for time period, and I've included the units as well: meters for amplitude and wavelength, seconds for time period and frequency in hertz, and then the labels on the diagram should make sense as well. Note the wavelength can be drawn between any 2 points which correspond to each other, so these green arrows I'm drawing are also wavelengths. It doesn't have to be between two peaks. Now, before we look at the equations or the relationships which we need, let's have a look at longitudinal and transverse waves. So let's have a look at this animation. This shows particle motion in both transverse and longitudinal waves. So you can see that in the top picture, the particles are oscillating up and down, while the waves are moving to the right. So you can call that the direction of wave motion, or you might have come across the term direction of propagation of the waves. So that's the direction in which energy is being transferred. In the lower picture, the particles, if you look at an individual particle, it's oscillating backwards and forwards. Nevertheless, we still get waves. You can see waves moving from left to right. So again, it involves oscillation of the medium only in a direction which is parallel to the direction of wave motion. The definitions of transverse and longitudinal waves are couched in terms of the direction in which particles oscillate compared to the direction in which the waves move. Pause the video and have a go at writing the definitions of transverse and longitudinal waves underneath the words as I've indicated there. Answers in 3, 2, 1. Okay, there you go. So you could, oscillations is just a fancy word for vibrations, and you could also refer to the direction of motion of the wave as the direction of propagation. Let's look back at these examples that I've got down here. So we've got water waves, which are transverse. We've got electromagnetic waves, which are transverse. We've got sound waves, which are the best and most common example of longitudinal waves. And then, of course, we've got seismic waves, of which there are two types. There are P waves, pressure waves, which are longitudinal, and S waves, which are transverse. I've also included here gravitational waves, which were only discovered recently in 2016. Gravitational waves are transverse. They're not an example I would include in an IGCSE answer, however. Let's look at some relationships now. There are two equations you need to know. One involves wave speed, frequency, and wavelength, and the other involves frequency and time period. Pause the video and write them down now. Answers in 3, 2, 1. Okay, those are the equations. Note I've included the units. Wave speed has to be in meters per second, frequency has to be in hertz, wavelength has to be in meters, and time period has to be in seconds. In a minute, we're going to use these equations to have a go at the calculations below. First, however, I want to come back to this. Okay, now this is a video of me playing with this Java applet, and I'm going to rewind it and we're going to watch it. Okay, this is a set animation of wave motion, and you can see I've got an oscillator on the left-hand side, moving up and down, generating waves which are propagating from left to right. Now if I place this vertical ruler somewhere as a point of reference, what I'm going to do is I'm going to start the timer, and I'm going to time the time it takes for 20 complete wave cycles to pass the left-hand edge of the ruler. So, 3, 2, 1... Go. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So, 20 wave cycles in 13.29 seconds. Note the frequency I've set is 1.5 Hz. Remember those numbers. 20 cycles, 13.29 seconds. A frequency of 1.5 Hz. Okay, let's write those numbers down. So we've got 20 wave cycles, and that took 13.3 seconds, and the frequency that was set was 1.50 Hz. What I would like you to do is confirm using these two pieces of information that the frequency is in fact 1.5 Hz. So we've set it on the applet to 1.5 Hz. Did what we measure, 20 wave cycles covering 13.3 seconds, confirm that? In addition, it would be good if you could calculate the wave speed using this information. Okay, so I'll let you pause the video now to have a go. Answers in 3, 2, 1. Okay, you'll notice that we get 1.5 Hz, which is good. You'll also notice that at the last minute, showed you that the wavelength you can read off the ruler as 4.2 centimeters, and then I've used that to work out the velocity of the waves, which is about 6.3 centimeters per second, which, if we think back when we were watching the video, is about right. Okay, now what we're going to do is try a few more calculations. You can see there are two sets of 6. Both sets will use the two equations above. You need to be careful of units. Otherwise, you can try as many of them as you would like. Pause the video and have a go now. Answers in 3, 2, 1. Okay, there are your answers. Be careful of units. So if you got answers different from mine, look at things like megahertz, centimeters, kilometers. Make sure you've got that right. You'll notice that at times I've used standard form. You should be comfortable with that now. However, hopefully those are okay. Let's quickly look back at the syllabus statements. There are 3 which I'm going to look at in a separate video now, because otherwise this one will be too long. We're going to look at the Doppler effect and general reflection and refraction in another video. I'll also discuss wavefronts at a later date. Otherwise, we've covered everything. Thank you very much. Goodbye.